Alright, again, rational inequalities, you are not allowed to cross multiply. So this negative x minus 2 is the same as negative x minus 2 over 1. Please never start crossing multiply this one times this one, this one times this one. Immediately you do that, you're automatically wrong. So to just make things easier for you, I'm going to say this is over 1. Okay, and then I'm going to get this term, take it to the other side. So what we are going to have is 2x minus 6 divided by x plus 3. If I take the negative x, it becomes positive x, right? If I take the negative 2, it becomes positive 2, and that is over 1. And the mistake that you can make for this one is extending this. Extending this, please. That is a big mistake you can make. Alright? So that is a very big mistake you can make. That is less than 0. If I want, I will still put a 1 in the denominator. And then from here now, merge this as a single fraction. Get what is on top of the first fraction, multiply with what is down the second fraction. That will still give you 2x minus 6. Get what is down the first fraction, multiply with what is on top of the second fraction. That will give you plus, alright, x plus 3, and then alright, x plus 2 because I'm multiplying. And then multiply the two denominators. That is just x plus 3. Okay, that is less than 0. From here, we have got 2x minus 6 plus, I'll multiply this x times the x there, that is going to be x squared, x times 2 there, that is going to be 2x, and then 3 multiplied by x, it is going to be 3x, and then 3 multiplied by 2, that is going to be a positive 6. The denominator only has x plus 3, and this is less than 0. Now on top, I'll start by writing the one with a square, that will be x squared, and then I'll add like terms. 2x plus 2x 4x plus 3x 7x. Okay, that is positive 7x. And then we can see this is negative 6, this is positive 6, so they'll cancel out, right? And then divided by x plus 3, that will be less than 0. So on top, x is common. What am I going to do? I'm going to factorize out x. So let me write this side. So I'm going to say x, open brackets, x plus 7 divided by x plus 3 is less than 0. Now at this point, this is the point I want to pause again. Is everything okay up to this point? Are we okay? Do you have any questions up to here? Any question?
Yes.
Yes, what's the question? Or you mean yes, it is clear?
Yes.
Alright. So from here, equate everything to 0. Get x, you equate it to 0. Okay? So if I equate x to 0, I'm going to find that x is equal to 0. And then get x plus 7, also equate it to 0. You're going to find that x plus 7 is equal to 0, and x is going to give you negative 7. First value there, second value there, and then get also the denominator, equate it to 0. So that is x plus 3 is equal to 0. You're going to find that x is equal to negative 3. So these are the three values that we have. And then again, I'm going to draw a number line. Now it's a special number line because you might not think it is a number line, but it is a number line. But I'm going to also include the factors on this number line. So I'm going to get those factors which I equated to 0. The first one I equated to 0 is x. I'm going to put it here. The next one I equated to 0 is x plus 7. The next one I equated to 0 is x plus 3. The values which we found, writing them in increasing order, the smallest is negative 7, followed by negative 3, and then the biggest is 0. When I equated x to 0, I found 0, meaning that for x, the point that is going to determine the change of signs is 0. What happens if I use any value of x greater than 0? I put where there is x. Like any number that is greater than 0 is positive, meaning that if I put where there is x a positive number, it will be positive. Immediately I cross 0, I'll just find negative numbers, and if I put them where there is x, they'll be negative. When we equated x plus 7 to 0, we found negative 7. Meaning that negative 7 is the determinant of signs, or that is where signs are going to be changing. What happens if I use the values of x greater than negative 7, like a negative 6 or 0 or 1? I put here, it will be positive. So as long as we are greater than negative 7, the answer will be positive. Immediately across negative 7, it will be negative. What happens when I use great values of x? Of course, when I equated x plus 3 to 0, I found negative 3. What happens if I use values of x greater than negative 3? Like a negative 2 or a 1 or a 2. It will be positive. Immediately I cross the negative 3, it will be negative. Remember, this is dividing with this. So we are interested in the quotient of signs. Negative over negative over negative, or negative times negative, that's a negative. Negative times negative, positive. Positive, positive, negative, negative, positive, 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 positive. But for this inequality, we are interested in where x, the function, is less than 0. And less than 0 means negative. So it is from here going in this direction. And then from here up to here. So meaning that the solution set for this inequality, you always start with the smallest. The smallest is always this side. Where is the arrow going? Is to infinity. Like whenever you see an arrow, you don't know where to end, so just put infinity. But because it's going to negative numbers, that's why I say negative infinity. Otherwise, if the arrow is going like this, we'd say positive infinity, because it's going towards positive numbers. We know that's how a number line is. So the smallest value is negative infinity, and then as you get to follow this line, it is going to pause at negative 7. So negative infinity comma negative 7. So we are, you can see that this place is open, so we're going to use this bracket. Negative infinity, always use it, like for infinity you always use this kind of brackets. And then you say union, you can see also from negative 3 up to 0. And this is also open here, also here is going to be open. So this is the solution set to this question.